Hello, I am Satyanarayan Soni and today we will discuss projectile motion. Projectile motion. In projectile, what is projectile motion? Projectile motion, if you throw any object with any angle and it will fall under the gravity, then this kind of motion is known as projectile motion. Means any object throw with any angle in any direction under the gravity, under the force of gravity, then this kind of motion is known as projectile motion. Let's suppose we throw any object at angle theta from the horizontal with velocity u, then its path will be like that and its component of the velocity will be horizontal component will be u cos theta and the vertical component will be u sin theta. We have to find out the velocity at any point, and what are the conditions. First we can discuss the condition for projectile motion, like angle like gravitational acceleration will be negative condition, or assumption we can say, for projectile motion. First, gravitational acceleration small g will be negative always, and air resistance will be negligible. Air resistance we can say will be neglected. Now we can study about the projectile motion when we throw a ball from the horizontal, means ground to ground projectile. Ground to ground projectile. When you throw a ball with velocity u at angle theta, then its horizontal component will be u cos theta and the vertical component will be u sin theta. And we have to find out the velocity at any point p, like if I say here point p, I have to find out the velocity at this point. So the horizontal component of the velocity at point P is u cos theta ik, and vertical component of the velocity at point P is u sin theta jk. From kinematic equation, from first kinematic equation, we can write v equals to u plus at. Here v is a velocity at any point p, u is initial velocity, so u will be u cos theta I cap plus u sin theta j cap minus gt j cap, because it's always be negative. If we find out the velocity, we can find out the maximum height. Maximum height. We already know that at maximum height, velocity, vertical component of the velocity will be 0. Then from third kinematic equation, we can say v square equals to u square plus 2as. S is a height, so v square equals to u square, and we already know that acceleration will be negative, so we can write like this, and the velocity will be 0 at maximum height, so it will be 0, and u will be u sin theta, it's initial velocity in vertical direction or in y direction. So h will be u square sin square theta by 2z. We can find out the horizontal range, or we can find out the time of the flight first. Time of the flight. The flight. We already know that displacement in vertical direction, displacement in vertical direction will be 0. So we can say from third kinematic equation, s equals to ut minus half gt square, because g will be negative and vertical displacement is 0, so we can say s equals to 0, and u will be u sin theta, vertical component in y direction, into t minus half g t square. T will be 2u sin theta by z. It's the time of flight in whole projectile motion. And we can find out the horizontal range. Horizontal range. It's a horizontal distance covered by the projectile during projectile motion. So we already know that in horizontal direction, the component of the velocity will be Vx equals to u cos theta, and it is responsible to cover the horizontal direction. So distance covered in horizontal direction will be distance equals to velocity into time. Velocity will be u cos theta, and time will be time of flight, means 2u sin theta by g. If we will solve this equation, we will get 2u sin theta into u cos theta by g, 2u square. So we can write u square 2 sin theta cos theta by g, or we already know that 2 sin theta cos theta will be sin 2 theta, so it will be u square sin 2 theta by r, means range in projectile motion.